recording. Okay, so today's little seminar starts off with this marvelous logo we have in front of us from an institution that some of you might know. So I'm going to already start with a little bit of a question, which is, do you guys know what this is a logo for?
Is it MIT?
Who said that? Was that Jonah?
It was Tom.
It was Tom. Sorry, Tom. It is true. It is MIT. Has anyone considered joining MIT at some point in their future careers?
I want to go to MIT. I want to go to MIT.
Okay, cool, yeah. So some of you already know what MIT is, and it is, at the moment, it has been for a very long time, kind of the haven for technology enthusiasts and people who are really engaged into creating creative stuff with science and technology. And this story starts here at MIT, before MIT Media Lab, before all of that stuff. It was just an institution for well-developed and really creative scientists. And among those people, there were a band of something they called hackers. You've guys heard of hackers before, right? Yeah. But so what do you think about when you think about a hacker? What does a hacker do?
Maybe break into security and stuff.
Okay, break into, like, past security boundaries, hack passwords and steal things from databases, that kind of stuff, yeah? Anyone else have something that they think about when they hear the word hacker? Well, back in the day, when this word was invented, it had nothing to do with breaking security clearances and stealing things or anything like that. It had just to do with taking the current technology, the newest stuff that was out there, breaking it apart and see what you could do with it. Maybe you could improve it. Maybe you could see when it failed. Maybe you could do something that no one else had ever thought about. So this group of students decided to form a little after-school activity, almost like curly brackets in some ways, that was called the Tech Model Railroad Club. And that's what you can see pictures of here.
I know the guy in the right bottom corner. He was the guy who made artificial intelligence.
That is completely true. How did you know that, Tintin?
In science class, we have to choose a scientist, and I chose that guy. I forgot his name. Actually, I'm just gonna quickly go to my Google document and check out.
Yeah, please find his name. I'll continue in the meantime, and then you just say the name afterwards. Is that okay? Cool. So they started off literally building railroad models, which back in those days involved a bunch of knowledge about electronics and mechanics, and you had to plan out all this stuff. So it wasn't just a playful, like a toy. It was a serious project that you could work on your own, and you learned a lot of stuff from it. And then, by the way, has anyone ever... by the way, I'm recording right now, so you have to be quiet with the dog, please. Is that okay? Thank you so much. The dog loves to speak. Could you hear him in the background?
Yes.
Yeah.
Just a bit.
Yeah.
Yes.
Sorry about that. He's a very talkative dog. So he, So.
Oh, I remember now. It's John McCarthy.
John McCarthy. That is completely right. One of the kind of the godfather of artificial intelligence, right? So.
Yeah.
Has anyone ever worked with train models before, by the way? Like from your grandfather inherited or something like that?
Yeah.
Yeah? Is it? Do you guys like it?
I was sort of into it a little while ago.
Yeah, it's a pretty cool thing to be doing, and it does involve surprisingly, a surprising amount of skill to be able to handle it. Anyway, so after they did a bunch of stuff with train models and stuff, they kind of evolved into this playground for technology, and a lot of companies would send their newest stuff to the railroad club, and they would figure out ways to break it and figure out ways to do cool stuff with it. They were also, and one of the reasons why they've gotten so famous throughout the years is because they did these pranks. So in the picture to the left here, which is back in the 1960s, the club decided to take an old Chevy car, and they painted it and installed it with all sorts of different things that you would have to install to make it look like a police car. And they made a dummy of a policeman and dressed him up in a police uniform, stuffed donuts down his pockets, and they put it on top of the dome, which is kind of the main centerpiece building in MIT. And they left it there overnight. So here you can see how they displayed it. And a little bit of a more modern version is when they took a whole building in MIT campus and they made it into an actual functioning Tetris. So this game could be played. So I guess you would just have different light switches in rooms, and you would connect everything to a central computer, and you would turn on and off the lights depending on where the blocks were, and you could play Tetris doing that, which is pretty cool. I was going to suggest maybe we could do something similar at some point. Maybe we could ask someone if we could borrow their building and install it with a bunch of lights. I don't know. We'll see. But it's pretty cool anyway. So this club became absolutely infamous. Now, among the people who were in the club, you had these 4 people, 2 of which I didn't find any pictures of. But you had Steve Russell, which is kind of the main guy that the story is about here, who is one of the inventors of a programming language called Lisp. So when you guys start university at some point, if you're going to take computer science, you might use Lisp at some point. It's a very mathematical language. And Martin Gretz, who was an electrical engineer, he also worked on that language and played a key role in the stuff that we're going to be talking about later. Bob Saunders, who is the last guy here, he was an electrical engineer and he ended up being working at MIT later in his career. Wayne Vittanen, I have no idea why he is mentioned in the making of the game that I'm going to be talking about, but he's one of the makers. I haven't figured it out. Maybe you guys want to try to figure that out for yourself. But talking about the introduction of new technology and what you can do about it, these 4 people were working in the railroad club, and then a company all of a sudden decided to introduce them to this new computer that they've been working on called the PDP-1. Now, it's a very famous computer, actually, so I'm curious to hear if any one of you have heard about this thing before. The PDP-1. No? So the PDP-1 stands for Program Data Processor, and the reason why it's called that is because back in the day when they made this computer, people recommended the company that made it that you shouldn't go into the computer business because it is too hard to get things sold. So this was before, IBM and the personal computer and all that. They said that it's too hard of a market. So what they decided to do was to go into the market anyway, but they called it a program data processor, which is not a computer, but it is a computer. Okay? It's just a marketing stunt. And here you see it, all 735 kilos of it, because it was a pretty substantial thing. It wasn't a portable device, but it was the first computer ever that had an actual display baked into it. So you see this thing on the side here, which you can also see here, which is a radar display. And the way that this thing worked is that you had something called a cathode ray tube. Have you heard about that before? The reason why it's famous is because the old televisions back in the day, back in 1980s, 1990s, they used cathode rays. And what they basically are mini particle accelerators. So a particle accelerator is basically just a thing that it's like a gun, and it shoots out tiny particles. And that's what you can see here on the screen, these tiny little dots. And they have super high precision, so they can shoot it out exactly where they want it at super high speeds, at super high frequencies. And then if you just do it fast enough, and if you do it precisely enough, you can create these patterns on the screen. And this is how a screen technology used to work back in the day, just shooting stuff at a screen. And the reason why it lights up is because on the screen itself, there's a thin film of something called phosphorus. Have you heard about phosphorus before?
Yes.
Yeah. Phosphorus basically interacts with these particles and it creates this light. And it takes a little bit of time for it to fade away. So that's why you see these trails of green that's kind of all over the screen here. And just so I don't spend too much time talking about this before I get to the actual thing, I just want to say one more thing, which is down in the corner here. This is the first light pen that you could use to actually draw on the monitor. And this was, these days this is quite normal, but it's kind of surprising that back in the late 1950s you could already draw on screens like this using something called a light pen. And what it does, it just looks at the monitor and it kind of sees what pixels are being lit up. And then it tracks where the pen is moving, and then it translates it into this drawing you can see on the screen. But you have to do it pretty slowly because the computers weren't very fast back in those days, so it couldn't track it very quickly. But to the next and most important invention about the PDP-1 is this thing called punch film, I believe it was called. And you can see it up here in the corner, up here. And what it is basically the first way of being able to transfer software from one place to another, or at least the first efficient way of being able to transfer software from one place to another. So if you wanted to install, for example, a game on a computer, or I don't know, a word processor or something, you would write that word processor using these dots and then fold it up or curl it up in a roll like this, and you would feed it into the computer in this thing in the middle here. It would take a little bit, maybe a minute or two, and then the whole computer would be filled with the software from this thing, and you could only do that one program at a time. So in this case, where the MIT people have made this crazy chaotic thing going on, it's one of these films that translates into this software. So you can see how tedious and time-consuming this was back in the day, except this was a great progress compared to those old punch cards that you would use, where you would put one card in and it would take forever to be able to install any software. So this was the right time to be able to be a hacker, where you could create your own software, because you could create this and you could share it with other people and they could install it on their own computer and make adjustments. So this was the right time and right place to be if you wanted to, for example, create a video game. Which is why this, what this first guy, Mr. Russell, or Steve Russell, did, after reading a science fiction series called the Lensman series. And it was about this alien race versus human race that lived on opposite sides of a galaxy somewhere, and they would go to war with each other. So this was written very quickly after the Second World War. Everything was about war and dominance, and the alien race probably symbolized the Nazi Germany, and the humans were the allies, and they were supposed to defeat each other. And this is what he had to say about this Lensman series. So his heroes had a strong tendency to get pursued by the villain across the galaxy and have to invent their way out of their problems while they were being pursued. That sort of action was the thing that suggested Spacewar. He had some very glowing descriptions of spaceships encounters and space fleet maneuvers. And so this inspired him and to envision this thing you could play on a display. And so this was probably something that he had in mind. This the spaceship versus another spaceship, and this thing in the middle, and you're supposed to shoot each other. Now he started coding, and it took him about 3 weeks to finish it. 200 hours. I'm not so sure how many hours that is per day, but it's you could do the calculation. It's a pretty significant amount. And this is the actual code that was written. You see them in the columns down here. Actually, I can show you the entire code, which I have here on the side. You can't actually make this work on this computer. You would have to have like an emulator or something. But it's line by line is one character. And if you look at the game, the way that it was played, you have these torpedoes you're shooting at each other, and you have this fuel that lets you propel yourself with a ship around the screen. And you can see here that you have torpedo velocity, torpedo life, fuel supply, and it's all written into memory on the computer using these numbers here. So quite a tedious way of programming, not at all like we're doing today, but even nonetheless a giant leap in the right direction. So he finished this thing, and afterwards they made this controller, and it was possible to play it on the screen. And this is the result. This is basically the entire game. And it's a 2-player game. There's no artificial intelligence. There's no enemies that do make their own choices. This is a 2-player game, and you have to avoid crashing into the star in the middle. But the star has gravity, so you can see that the ships are kind of getting sucked into the gravity field of the star. And you can use that star to maneuver around and do interesting strategic maneuvers. And all you need to do is shoot the other ship once, and then you win, and you start over again. There's also one last feature, which is hyperspace. So if you're in panic mode, you can press hyperspace, and then you can be transferred into a random location on the screen. And then for
I know
every...
that game. It's like when I was going on a long airplane flight, you could play that game.
Could you really?
Yeah.
That's so cool. So I mean, these days there's been a bunch of remakes. You can play these things on like WebGL or using a web browser.
Except in the version, there's a lot more enemies, and it takes way more hits than one hit.
Yeah, because these days computers actually can handle that amount of memory. But back in those days, this literally consumed the entire memory of the computer and all of its processing power to be able to do this. So it was made to be able to have fun as a game, but it was also made so that you can demonstrate how much this computer could actually process at the same time. That's very important to know, because back in those days, there was no market for video games. There was no possibility to sell stuff for the commercial market. These things were made either just because you wanted to, or because the computer companies wanted some kind of a demonstration of what their computers could do. So you could sell computers, not computer games. So anyway, it's been used as an inspiration for other games since then, like Asteroids. That was made for arcade machines back in the late 1970s and early 1980s. And it's a lot of the times when people are beginner game developers and they want to learn JavaScript, for example, these are like beginner projects that you could work on. Now, just to finish off, because I can see that I've been doing this for quite a while now, I made, like I will continue to do, I made a little version of my own in JavaScript, and you are very welcome to tell me if you want the source code for it. And it's basically a little prototype where you have health, and this thing in the middle is the gravity well I was talking about, and you can see that it kind of sucks me in when I go over the red line, and I can shoot the other ship, and it's gonna lose life. And I only have a...
see the other ship.
Yeah, the other ship is the other triangle over here on the side.
We can't see it because...
Oh, you can't see it? What about now?
Yeah, now I can see it.
You can see it now? Yeah. And it's super simple little prototype.
The other ship doesn't move.
It's because it's a 2-player game. So if I use this other thing, I can move it around. Woohoo! You see? So it's a 2-player game. It's not any artificial intelligence. But I thought maybe, next time I could maybe code in some artificial intelligence into it and see how long I can get. But it takes a while to do that. So I didn't have time for it on Sunday, unfortunately. But the only difference between this game and the original one is that here you can also bend the bullets. So if I'm shooting inside of the gravity area of this star, then you can see that I'm bending the bullet, which I thought could be kind of a cool game concept. Maybe you could create some puzzles and some cool scenarios where you're putting out a bunch of these stars and you have to use the gravity field to be able to hit the other players.
You could do that, the little circle at the bottom?
Yeah.
You can have that mirrors the bullets. So you could shoot there, then you move out, and then it bends the bullets.
Yeah, that would be really cool.
Something.
That would be really cool. So if you guys want to try to create a game that it's better than this one, then go ahead and I will give you the source code. From now on, by the way, I'm going to be pushing everything that I make on Sundays onto GitHub. So I'll give you the link, and you can just follow. You can follow there and see when things get updated, and just make your own versions if you want to. Yeah.
I just wanted to say that there's a really cool documentary on Netflix called High Score, which is about the history of video games.
Yeah, thank you for saying that, because Raf had recommended that to me last week, and I just watched the first episode.
I'm watching it. It's really fun.
Okay, you
about,
got
like old games like Atari, and like about all these old games that about how they're made and stuff. It's
awesome.
really cool.
Everyone should watch that then. Maybe that should be homework. Well, Tintin, give them homework.
It's a really good one.
It's like 6 episodes, and each episode is 40 minutes. So.
Okay.
And in the end of the first episode, there's a little crazy story that goes on for 10-15 minutes about a guy who apparently made the worst game ever made.
Yeah, I know
game.
that.
Yeah, don't spoil that, Tintin. But that is a really cool part. The story behind that is completely crazy. So
yeah, well, anyway, I'm done now. I wish I had like a moral of the story. Maybe the moral of the story is that technology combined with the proper environment to be able to create whatever you want, and then also some crazy idea, maybe from science fiction, equals a new crazy revolution. And you are in the right place, because we're trying to do the same thing in curly brackets. So maybe this is like just a giant 20 minutes commercial. I don't know. But yeah, okay, cool. I'm done. By the way, I will have one question. Would you guys like me to show off some more code and go more into the actual making of the games in these seminars, or do you want more history and and technology?
Personally, I like the history and technology.
You like the history and technology? Okay, good. I don't know how much I can do with this before it gets tedious and boring, because I haven't done much of it before. So give me some feedback. Tell me when I'm doing things right, when I'm doing things wrong, and I'll listen intently. Okay, good.